In this video, we'll be finding the MacLaurin series for sine of x, and we'll use this when doing a proof of e to the I pi plus 1 equals 0 Euler's formula. So let's get started. So first thing to do is define what the MacLaurin series is. So the definition is given by the function such that it's the sum from n equals 0 to infinity of the nth derivative of f when you plug 0 in over n factorial times x to the n. So that's the definition. Looks pretty intimidating, but we'll take it step by step. First step is to take some derivatives of our sine x function. So the 0th derivative of sine x is, and we're going to define here, I'll define up here f of x equals sine x, so there's no confusion. So keeping that in mind, the 0th derivative of sine x is just the function itself. The first derivative is given by cosine x. The second derivative is given by negative sine x. The third derivative is given by negative cosine x. And if you do the fourth derivative, that's going to give you sine x. So it's going to cycle back up here, and then it's going to just keep cycling like this. So there's only 4 possible derivatives. And when you plug 0 into them, because it's a MacLaurin series, and you're going to plug 0, it's centered at 0, from here you're going to get 0. From here you're going to get 1. From here you're going to get 0. From here you can get negative 1. So really the only values you're concerned with are 1 and negative 1. So let's start plugging in stuff into our expansion. So we're going to take that series and we're going to write out for some of the first terms. So we're going to have f0 of 0 over 0 factorial times x to the 0. So this term is just going to be, since when you plug 0 into the initial thing, it's just 0, this term does not even exist. So we don't need to write it. But if we have f prime 0 over 1 factorial times x to the 1, that does exist because that's cosine x and then you have 1. So the first term in our expansion is just x. Now the next one, if we do f double prime, remember that we're not going to have a derivative again, it's going to be 0, so we skip that. If we do f triple prime, so we have 3 everywhere, then we have negative 1, so it's going to be minus x cubed over 3 factorial. Now, again, the fourth derivative doesn't matter, so we're going to do the fifth derivative. So the fifth derivative, and everything's going to be a 5 and a 5. That's going to go back to the original sine x, and it's going to be, or it's going to go cosine x, and it's going to be 1. So we're going to have plus x to the 5 over 5 factorial. And due to the nature of sine and how it just keeps alternating, how it just keeps, the sine will just keep alternating and the function will just keep going through those 4 derivatives, we can just predict the next ones. I'll give you x to the 7th over 7 factorial plus x to the 9th over 9 factorial, and so on. So it's every odd power, every odd factorial, and alternate the signs from negative positive, negative positive. And that makes it really easy to solve for values of sine to extreme accuracy. So we'll use this in the proof of e to the I pi, and the one for cosine x can be derived in a very similar way.